Have you ever put months of effort into a project only to launch it and find users are just frustrated, their needs are met, and the business goals are nowhere in sight? Like a bridge that leads nowhere, painful for the team and disappointing, like spending weeks preparing for a presentation and then realizing halfway through it that you're screen sharing the wrong window and suddenly everyone's been staring at your very personal tab collection for half an hour. I mean, that was overly specific. You get the point. Just move on. Welcome back to the Semaphore channel. I'm Fernando, and in this video, we're mostly going to be talking about BDD, or behavior-driven development. So let's go. Today, we're traveling back in time
to see the evolution of software development from the rigid models like waterfall to the flexible and revolutionary BDD, or behavior-driven development, which is our best bet against the evil scum of project failure.
You get the point. So let's go back to where it all began, with the waterfall model. But before we go any farther, let me just explain why we're comparing waterfall with BDD here. I'm very aware that on the surface, these two concepts are very dissimilar. When we look at waterfall's structure, step by step, and very locked in phases, it's very clear that defining requirements from the get-go it's critical. But it can be a tough thing to do if you don't have a common language, something that is understandable between all parties involved in that definition. And that is where BDD comes into play, essentially. While it's typically paired with agile methodologies, BDD can actually bridge some of waterfall's biggest gaps. It's all about making sure that everyone's on the same page from the start of the project and throughout the lifespan of the project. So now let's get going. The waterfall model was first introduced in a 70s paper by Dr. Winston Royce, and the paper was titled Managing the Development of Large Software Systems. Imagine a cascading waterfall, essentially. It starts with the gathering requirements and then moving on to design, development, testing, and finally deployment. The waterfall model was essentially inspired by existing engineering and manufacturing processes at the time, which typically involved a sequential set of steps. In those fields, usually one phase needs to be completed before moving on to the next one, because changes are typically very expensive in certain phases, like when you're building structures or designing circuits, for example. Those are moments where once you've done it, actually building something physical, making changes at that stage means going all the way back to the design stage and essentially starting over. The model's clear flow, one step after the other, was very appealing in the software industry, and that's why it was widely adopted at the time, because also the industry was looking for predictable timelines and structured processes that you know people could follow and fall into, essentially, and develop products around them. But here's the thing, Royce didn't really present waterfall as a perfect solution. He pointed out its flaws, the main one being that putting testing right at the end of those steps. If you remember the waterfall we covered at the beginning, testing was right almost at the end, right before deployment. Royce actually noted that delaying testing until that stage meant that issues would often be found way too late in the process, and that would cause a huge delay on and budget overruns, essentially, because you would have to go all the way back to the early stages of that waterfall to fix the problem and then cascade down to the new testing process. That meant that during the waterfall process, developers would hand down their code to the QA, to the testing team, right at the end, where they had done everything, every feature was developed, everything was integrated. The next step was just deploy to production. So before that, the testing team would just find tons of bugs, send them back to development, who would have to push up the waterfall, the code, the process, essentially the definitions, until they found the step where the solution could be implemented, and then go back down all the way to development and then testing again. That process would usually take weeks to solve the problems and to retest again. You can guess what that meant for projects overall, from the budget perspective all the way down to the morale of the team. You could guess that this could be one of the major reasons why there is such a rivalry between the QA team and dev teams in most companies, even though that now waterfall processes are usually not that common, and agile methodologies allow for much faster feedback loops, which we're going to talk about in a minute. But this could be one of the triggers for that kind of toxic relationship where developers would work on something for months on end, thinking that everything was ready for deployment, and then just find out that they had to go back, redesign a solution, and then retest again, hoping that this time around the changes, after weeks and weeks of more work, the changes would actually go into production. I wouldn't be happy if that was me, so I can imagine it. So waterfall gave us a pretty good structure, not perfect, but it was great at the time. But it also taught us a very important lesson. To build better software, you need a continuous feedback loop. It's not just about working on it until it's done and then test it, but rather make small increments of code and then test those increments, provide feedback to developers, and then keep going. So that's where everything started shifting to the left, if you will. Instead of waiting until the end to test it, developers began creating their own tests early on. Write a bit of code, test it immediately, get the feedback, figure out what to do, move on. It sounds simple, but that huge shift to the left made it so that fixing a problem took minutes instead of weeks. So everyone was much happier, and finding problems on a code base, finding problems on a feature didn't mean that the entire project would be delayed. Now, writing tests sooner, and this whole process I've been describing, didn't just introduce that increase or improvement in the dev performance in the entire dev workflow, but rather it also introduced the idea of automated tests. Once developers would write a test, they could automate it so that it would run on every change. It meant that after a while, they would have a full set of test suites that would test every corner of the code continuously after every change. It provided also sort of a safety net, allowing them to rest assured that whatever they changed, whatever extra code they added, didn't break anything they weren't aware of. Now, making that shift to the left, making tests something that was more common and even automated, was a huge improvement, but it wasn't perfect. I mean, it still had one major problem. Writing tests after the fact, writing tests after your feature is done, meant that the test would be usually quite coupled to the implementation of that feature, to the implementation of the code that the test is testing, essentially. So that meant that further changes in the code would break the test, even though conceptually the feature was still the same. Conceptually, the piece of code, the piece of logic was still doing the same thing. It just wasn't implementing it the same way. So the test wasn't actually testing the behavior or the expected output, but it was rather testing the implementation of the feature. And that was a problem. It turns out that the order in which you do these things actually matters. So writing the tests prior to writing our code forces us to really think about the problem and look at the solution from the outside, trying to think of what it should do instead of how it should be implemented. This is essentially the basis for test-driven development, or TDD. After this change in mindset, it quickly became obvious that this cycle of write a test, write a code to make the test pass, and then improve the code and start over, it would just drive design ideas more organically. It essentially, we start to implement only the things that actually need to be implemented from the design, from the business requirements, and we write them in a way they can easily evolve. So we don't couple the features or the implementation with anything else. If you're interested in TDD, this is not a video for it, but I actually have another video in the channel where I cover everything about TDD that you need to know about. So if you're interested in TDD, just make sure to check that video out. Now, in a continuous search for improvement of this cycle, let's just stop for a second and double down on the analysis phase. Essentially, by analysis, I mean understanding what needs to be built. So the analysis phase, or this particular phase, call it whatever you want, in the waterfall world, it meant defining essentially dozens of or more of features, and then handing that list over to developers who would just work on it until the full list was over, and then we could move forward. In an ideal world where everyone knows what they want and how they want it and how it needs to work way before the first line of code gets written, that would work. But that's just the ideal world. In reality, that's never the case. Never. The actual real world is messy. We end up usually implementing features that we don't really need, or we end up discovering features that we actually need and didn't implement. So we make another shift, we make another change, another update on our cycle, and now we add the analysis step into a process, into the loop essentially, and now we can test drive features before we move on to the next one. After applying this technique consistently, after a while, we start to notice that we tend to break down these features in the smallest units possible, and we consistently develop them and deliver them one by one. This allows us to identify and discard features that we don't really need, and only work and only prioritize the ones that actually need to be built. And this, finally, it's what's called BDD, or behavior-driven development. BDD expands essentially on TDD by bringing business requirements into a feedback loop. We're not just testing and making sure that the code works, we're also double checking that what we're building actually makes sense. It's actually required by an updated set of business rules. And if you want to simplify it, with BDD, we focus on the what needs to happen so that we know it's a priority, instead of focusing on the how it needs to be implemented, whether we need it or not. Now, one of the beauties of BDD is that we can actually express scenarios using just regular language. Usually English, we can express scenarios just like speaking or describing it using our own language. We don't need to learn a specific dialect or a specific language that is like a programming language, if you will. And this is what it looks like. Gherkin is the language designed to make scenarios easy to read and understand. From here, we can implement the actual scenario in any language or using any tools that we want, like Cucumber, for example. Many unit tests suites like Chest also let us write tests using BDD, using Gherkin, the way you're seeing right now. In this scenario, in this particular scenario, we're describing the behavior that we want. And notice how we're not specifying anything technical at this stage, like how the search functions or the layout of the blog on the web page or anything really. Instead, we're just focusing on the actual experience that we're looking for. And now let's face it, there's always been some level of controversy when we look at TDD or BDD. There are always people who love it and swear by it, and there are others that essentially hate it with all their heart and would just rather resign than to actually work using one of these methodologies. Problem, and like usually happens, is that this hatred comes from actual misconceptions about the methodology that we're talking about. So let's try to look at some of the biggest myths or misconceptions about BDD that are just running around the web. One of the biggest ones is that BDD is just for either UI testing or end-to-end testing, and this is incorrect. BDD is not limited to having a user interface. Actually, you have to think of BDD as a way to describe behavior, which can be applied to many levels, whether you're actually using a user interface or just describing the behavior of an API or some sort of process in the backend. Again, just remember that the focus of BDD is just the what has to happen, not the how it needs to happen. And let's look at another example to explain what that means. Now, this scenario focuses on the UI elements. So we're describing how a user is logging into an application. And right now we're referencing the username field, the password field, we're referencing the login button, and eventually we're talking about the dashboard. This makes for a very fragile test, if you will, because the moment the UI changes somehow, it will probably break. This is what I was referring before when I said coupling the tests to the implementation. Here we're coupling the test to how the UI is implemented. If you change the username field to something else, or if you just change the way the user needs to authenticate, now suddenly this test fails. The problem is that in BDD, that shouldn't really happen because we need to consider the actual behavior that we want out of this interaction. So instead, if we look at the second version here, where we just say that given authorized user called Sean, it's when they are successfully logged in, then they need to be able to see their dashboard. Essentially, that's all we want. That's kind of what we were getting at on this version, but this focused too much on the how it gets implemented and how we get to the dashboard instead of what needs to happen, which is when I successfully log in, I get the dashboard. That's it. That's really what I want out of my behavior test. So again, in this scenario, we're focusing on the what instead of the how, which is really what we need to always consider when we're writing our BDD tests. This way, they're less likely to break when something changes on the actual implementation, on the actual UI, and they would only break if the behavior associated with the feature changes. For example, if we were to now redirect the user to their main page, which doesn't really have dashboard, for example, in that case, sure, the test will fail, but it makes sense for it to fail because we actually change the expected behavior. Another common misconception is that BDD is only useful at a high level type of testing or an end-to-end type of test. And that's also incorrect. You can use BDD with any type of test within the testing pyramid, if you will. You can use it with integration tests, but you can also use them with unit tests, and you can even use them with acceptance tests. Really, this is not about focusing on one aspect of the testing environment, but rather a way to think of these tests, a way to implement or come up with what needs to be tested. So again, let's take a look at another example to see what that means. Here we're using BDD to describe actually a very specific behavior at the unit test level, to be honest. We're not testing a full application here or any kind of user or full user flow or anything. We're just verifying that our function actually adds the two numbers as we expect them to. This approach can be applied at any level, again, on testing pyramid, making BDD a very flexible and adaptable tool, to be honest. Another way of seeing BDD incorrectly is to think of them as only useful for unit testing. And you can see the pattern here on the type of misconceptions. Essentially, nobody really knows what BDD is good for. And again, the key here is that BDD is useful for all type of tests, not just for unit tests, not just for high-level tests or end-to-end tests. The key to get BDD right is to get the granularity level right. Usually, the more details that you add to a test, add more context, which tend to be better for the test, describing better the test. That said, in the case of BDD, you need to balance the what and the how, essentially. You need to see when you're going from adding just enough context for it to keep focusing on the what, and when you start adding too much context and you now suddenly are focusing on the how the feature gets implemented. And if you're having really difficulty figuring out where one ends and the other one starts, just think of the login feature that we covered before, the login scenario. The moment you start describing the type of fields that are there, the type of buttons that need to be clicked and so on, then you're suddenly are on the how it gets implemented land instead of being on the what needs to happen land. You know what I mean? So again, instead of saying the user enters the username on the first field and the password on the password field and then clicks on the login button, just think about when the user logs in successfully, something needs to happen. That's your BDD. The other one is just something else. And you know, there's not really a hard rule that you can follow that will solve this problem for you. You need to use your own judgment here and figure out where you draw the line. But again, you know, that's also a skill that needs to be developed. So maybe at the start of your BDD process, you might end up fudging some tests and overly explaining or adding too much context into some of them. But you will likely catch those tests when things start to evolve in your UI or in your implementation or wherever you're testing, because the moment those features change on how they're implemented, the test will fail and you'll be able to see whether the failure makes sense, and you can go back and adapt and improve the test. This is just an iterative process. Your first BDD implementation is not going to be perfect, but you have to do it once and then move on to the next one and the next one, and each little bit, you're making improvements and you're going back and fixing things that weren't rightly implemented at the beginning. That's how you learn. All right, now that we know what BDD isn't, let's kind of focus on, what you really get out of this process. Up until this point, we kind of cover what the biggest misconceptions are, and we also kind of cover at a high level the benefits of BDD and why you would want to use it for your project. But let's double down on that and try to understand what benefits you're actually getting from a process like this. The first one, and we kind of also hinted at it already, is that through the use of BDD, you're focusing on developing and testing what really matters, the features that actually are needed by the user. This is key. Even though BDD is a testing tool, it's a testing framework, if you will, it also adds that extra benefit of acting as a tool of validation. Through the process that we described already, you're actually constantly validating and revalidating the needs of your user and the direction of the product, whether it's going that way or not. Another huge benefit that you get from implementing correctly BDD is that you get cross-team collaboration. By that, I mean, this is not just about dev teams talking and working together, but rather dev teams talking to business talking to users talking to developers. BDD is allowing for a dialogue that goes in all directions, essentially. And if it's correctly implemented, it can touch all the areas related to the product, not just the implementation or not just the business selling this product or not just solely on the user and nobody else. We actually get to interact with users, we actually get to interact with developers, we actually get to interact with business, and through that dialogue we get to define the right direction for the product. We get to define the action need, we get to validate that we're moving in the right direction, and we do it on a short loop so that we're not waiting, like in the waterfall example, we're not waiting at the end to validate, to make sure that we actually build what we wanted to, but instead we're constantly doing it very quickly, going back and fixing whatever needs to be fixed and moving forward. Now, the last two are kind of byproducts of implementing BDD, but I still count them as benefits because you get them for free, essentially, out of the BDD implementation. One of them is clearer documentation, better documentation. We just saw how the BDD scenarios are written essentially in plain English, using a subset of English, if you will, called Gherkins, that allows you to, in a very human manner, express your expected behavior. That directly translates to documentation. You can easily put that in any documentation for your system, and anyone who speaks the language is going to understand them. It doesn't really need a master's degree. It doesn't really need technical knowledge to understand it. So that means your users are going to understand it. Whoever works on the project in the future is going to understand them, and the business is going to understand it. So that's a fantastic piece of documentation. And finally, the last byproduct, the last benefit of using BDD is the increased in confidence of your tests, essentially. Because again, this is not just about saying, I have 99% test coverage, we're good, but rather through the entire process that we've been describing across the video, BDD ensures that you're not just developing the features that need to be developed, but also that you're testing the right features and that you're testing it in a way that doesn't really couple the test with the implementation. So in other words, you're creating a very strong and stable test suite thanks to the use of BDD. And that is how BDD improves the process of building software, essentially. But before we go, let's really quickly go through the main takeaways from the video. First and foremost, BDD is all about optimizing feedback loops. Going back to the waterfall example, instead of just defining, designing, implementing, and then testing right before going to production, BDD allows us to have quick feedback loops around tests that are, or scenarios that are described using plain English. So we're not only reducing the time to fix a problem from weeks to minutes potentially, but we're also integrating business testing and user feedback into the development process. So we're making sure that whatever we're building actually needs to be built And when we do it on a more efficient way. So that's the main takeaway from BDD. Second takeaway is BDD is not the silver bullet for all testing, for every project, for every team. Like everything in tech, all needs to be taken with a grain of salt, and you have to put in what I cannot give you here in this video, which is your context, your team, your project, your requirements, your constraints, and then see if actually BDD is right for your project or not. It's a great tool, fantastic tool, but you also need to validate against your own context and figure out if it's the right choice for you or not. Remember, don't take my word for it, validate against your own context and figure out if it's actually the right choice for you. And finally, just think behavior. Think what needs to happen, not how it needs to happen, essentially. And that's it. Now we're done. Thank you. If you stuck to the end of the video, thank you very much. I hope it was enlightening and I hope you found it useful. If you did, just make sure to like and share the video with others, and remember to subscribe to the channel and hit the notification bell so that you're aware when we publish more content like this. Thanks for watching, and I'll see you around. Bye.